Hello guys, welcome back to JJK Masterclass. Guys, in today's video we will learn about the Jablonski diagram. The topic comes under photochemistry and you can find many more topics and videos on photochemistry on my channel like photochemistry of carbonyl compound, olefins, aromatic compounds. You can see Paterno Buchi reaction, isomerization and trans isomerization you can see alpha beta unsaturated molecule photochemistry you can notice. If you haven't seen those video, I will share the link in the description box. You can go and watch that videos, and I have basically solved the questions on that, so you can find it. And not only photochemistry, you can find the videos on my channel on pericyclic chemistry, spectroscopy, organic chemistry, name reactions, reagents, and you can find many more topics on first semester like analytical chemistry, titrations. So guys, do subscribe my channel and share it with your friends. Don't forget to press the bell icon so that you can get the latest notification. So now we'll start the question. You might get Jablonski diagram. You have to draw here, discuss about the fate of organic molecule when it is irradiated by photons or photoirradiation, or you have to describe the photochemical processes. So first you need to draw the Jablonski diagram, a very simple diagram where you label it properly and mention the names of all each processes. Here you can notice one is curvy lines, other is straight lines. So these curvy lines are the non-radiative process. I see the orange line are also the non-radiative process. You can notice that and other are radiative processes. ISE is also non-radiative process. So we will see what happens when a molecule is irradiated by electromagnetic radiation. So we know all the molecules virtually exist on the ground state, and so when the molecule is irradiated by the radiation, the excitation or absorption takes place. And so here the molecule will transit from S0 to S2. You can see here the vibration level S0 to S2, which is the highest excited state. The transition will take place from here. And the lifetime of S2 you can notice is very small, short, 10 to the power minus 11 second. So the molecule once reaches to S2, it will try to relax itself immediately and will come back to the more stable S1 lower excited state. So the transition from S2 to S1 is called intersystem crossing, which is a non-radiative process, and the lifetime of S1 is comparatively more, that is 10 to the power minus 8 second. And so you can find the photochemical reactions and other processes from this S1 state. So first is S1 may lose the energy as a photon and will come back to the S0 from S1 to S0. This is a allowed transition because the spin is not changing, and this process is called fluorescence. The other possibility is the molecule may come by a non-radiative transitions or non-radiative processes from S1 to S0. Here you will not see any radiation. The other possibility is the transition may take place from S1 to T2, that is the upper excited state. Since the spins are changing here, it is a forbidden process, a slow process, and called ISC, intersystem crossing. The lifetime you can notice for T2 is compared to S1 is more, 10 to the power minus 3 to 1 second. So the lifetime of T2 is more. You can find the chemical reactions from the triplet state compared to singlet state more. So the possibility is, since T2 is again the lifetime is compared to the other triplet state is less, so it will try to stabilize by releasing its excess energy and will come to the most stable state, that is T1. So the transition from T2 to T1 is called the intersystem crossing. The internal conversion, again you can notice IC, internal conversion, or once it reaches to T1, since the lifetime is more, you can watch here 10 to the power minus 3 to 10 second. The transition may occur from T1 to S0 either by emitting the radiation called phosphorescence, or it may come by a non-radiative process where you won't see any the radiation emitted, And so if you notice and compare the lifetime of fluorescent and phosphorescence, for phosphorescence lifetime is more, and so you can see the phosphorescence for longer period of time. So these are the fate of organic mechanisms, so photochemical reaction processes, which you can see once a molecule is irradiated. So I hope you understood what is Jablonski diagrams, what are the photochemical processes occurs here, what is the lifetime, and whether the process is radiated or non-radiated, whether it is allowed or forbidden. And you may get for 2 marks either of these questions to write a note on ISC, IC, or a phosphorescence or fluorescence, or you may get a full 4 to 5 marks category question where you have to describe all this. So I hope you understood it. Happy learning.